And our next speaker, and in this section of the day, the last speaker before we break, is Sawada, who is going to speak about prototyping the Kubernetes CRI, the container runtime interface, with Ruby and gRPC. He is a software engineer for more than 10 years and is based in Tokyo. And he's the father of 2 lovely daughters and plays the contrabass. Over to you. Can we have a hand, please?
Hi, everyone. Nice to meet you. I'm Kei. Came from all the way from Japan, and I'm really glad to be here. And what was most surprising to me is most of you speaks English very, very well compared to us, I think, and that is really surprising. So if you have a chance to come visit Japanese Ruby conference such as Ruby Kagi, then just talk to me. So maybe since Ruby Kagi is, I recommend that since in Ruby Kagi, there is many English speakers, so you will have some fun at that conference. And one thing I want to introduce at first is the hashtag Ruby Friends. So this morning, one guy talked to me, and yes, we talked about some Ruby topics. And after that, he took selfies with me. And he uploaded, actually, he tweeted that photo to Twitter. But I found that he didn't add the hashtag RubyFriends. It's OK if he knows and he intentionally do that. But if any of us still don't know this good Ruby culture, then I just want to introduce you. And so for today, just as an introduction, let me, is it OK to take selfie with you all? Is that OK? That's nice. So maybe let's try. So it's something like this. So can you raise your hands? OK, say cheese. Yay. Good. Thanks. I have tweeted. So if you find any Ruby friends at any place on the world, then and if you tweet your photo with this hashtag, then maybe some of your friends on the Twitter can also find, and maybe next time, maybe someone can say hi to you. Anyways, so this is just introduction. So let me start my talk, since I'm talking about the Kubernetes today. So I just want to, yes, at first, both time. So how many of you guys are right now using container for your work? OK, thank you. Maybe 50%. So next is, how many of you guys is right now using Kubernetes for your work? OK, it's kind of 10% or something. Thanks. And the lastly, how many of you guys ever implemented your own Kubernetes CRI implementation? Maybe that graph is not related to my talk, right? OK. Anyway, so my talk is all about the container and Kubernetes. So since I'm working for some Japanese company named Recruit as a server-side engineer, and actually right now I'm working as an engineering manager, but previously I was working as a VP of engineering at some subcontractor companies. Throughout those experiences, I have learned that to create, maintainable cloud infrastructure is really important to reduce or optimize our server cost or server running cost. So throughout those experiences, I'm these days doing some trying and experiment on container during my work. And throughout experience, I have tried something about Kubernetes. So I want to introduce about my story today. So let's start. Container runtime interface. But if you see this word, but first the question would be maybe what is what the fuck is container runtime? So is it equal to Docker? So think about that. Actually, not exactly the same. So container runtime is, let me define first. Container runtime is a something you use to manipulate container image. So it's not necessarily Docker. So Docker is one of implementations of container runtime. So there is other container runtime as well. So container runtime. So if you have you heard about Docker command line, Docker run some image, or Docker stop, or Docker RM, something like that. So anything you can manipulate about Docker image, about the container image, is container runtime. And aside from Docker, there is, on the world, there is some other implementation such as a Runshi, RKT, or Runway, or other container runtime as well we have. And most important thing is, right now, we have standardized specification for that container runtime named OCI specifications. OCI stands for Open Container Initiative. So we have already standardized container format so that from today, for example, you can create your own container runtime, for example. So that's the very important point. So if you have feeling some uncomfortable with your container runtime or container, then maybe you can start to develop some good, better product from today. Okay, let's go to the next step. So you now understand container runtime, right? But what the hell is container runtime interface? What is that? So let me explain about that. So container runtime interface is next. So container runtime interface is this part. So basically, container runtime interface is something you want to, how to say, something you can manipulate from outside of the network of the containers. So basically, CRI will be working as some proxy or interface to manipulate your container images from outside the network. And actually, the container runtime interface provides a set of APIs you can call from client application. So that's the important point. So now you understand the container runtime interface as well. And actually, other information is container runtime interface is built on top of a gRPC server. So APIs are called over gRPC. Okay, now we know. So summary at this point, until this point is, so Docker is just one of container runtime, but not the only one runtime, okay? And Kubernetes is using gRPC to manage container runtime. So that's why I introduced the container runtime interface, okay? So inside Kubernetes, gRPC is used, and the specification is really defined, and it's already open. So please remember the word CRI right now, okay? And okay, now we know CRI, container runtime interface, what is all about CRI, and it works about gRPC also, okay? But what kind of APIs are available actually? So that is the next question. Since we are developer, right? So that's why we love reading API docs, don't we? I do, actually. So let's check the API headers. Since it's built on top of gRPC, meaning that the interface is defined in the .proto file, right? So this is a snippet of the IDL taken from the CRI interface repository. So maybe you don't need to take very much detail about this, since I will upload these slides later on Twitter. So if you want to see, then maybe you can check out later. So you don't need to take memo, or you don't need to take photo or anything. Just listen to me. Or if you want to have lunch, then of course you can go out and you can have lunch, of course. Anyways, okay, then about the idea. So let's see the interface next. So what kind of functionality CRI provides actually? is basically there is two categories: runtime service and image service. So basically, CRI provides runtime and image. And for runtime, CRI provides creating pod sandbox. Later, I will explain about pod sandbox, but let's skip that about right now. And after that, of course, CRI can provide CRI provides the management functionality of the container. So, for example, if you want to create or run or stop some container, of course, you can ask CRI to do that. And other miscellaneous MISC APIs are also provided, but let's skip right now. And also image services. For example, you can ask CRI that what kind of image are right now available or downloaded, or also you can push your container image to the CRI as well. So those are the main functionality CRI provides. So now we know this is just summary, and maybe you don't fully understand about CRI, right? But just as a summary, CRI defines only 22 APIs. So you can read really quickly for runtime services and 5 APIs for image services. So that's really simple APIs, simple set of APIs are CRI. Okay. And about the pod sandbox, what is the pod sandbox is, maybe in this sheet I need to explain. So pod sandbox is something, maybe if you use Kubernetes, then you will encounter the word pod. So you need to understand that pod, but maybe the explanation from me is pod is a group of containers, including networking and metrics and logging requirements. So if you need to run a few containers at the same time, and those containers are working simultaneously or co-working over the network, then you need pod sandbox. Yes, that is maybe the best explanation from me. And more explanation, if you need more explanation, maybe you can Google or you can go to Kubernetes website. But at this stage, maybe just that's the simple explanation about pod sandbox. So, and CRI specification defines about those you can call container, how you can run container, or how you can create pod sandbox, or also how you can download or push images to the CRI is what CRI specification defines. And on the other hand, OCI defines their container, runtime, and image specifications, but that's too much detail for now, so just skip. So given this explanation, now I can maybe start my slides. So again, this is the slide title, right? So prototyping Kubernetes CRI with Ruby and gRPC. So now you understand CRI, okay? But what is prototyping Kubernetes CRI? So maybe I need to next explain about Kubernetes. So what is it like to manage servers using Kubernetes? Since many of us still don't have experience to manage or run servers or run our own servers on Kubernetes, right? So maybe just very, very quick introduction. What is it like to run servers on Kubernetes is something like this. So very quick. It's very quick, but these 2 lines of bash code is a configuration part, so maybe you can just only one time on the initial step you need. And for here, I type gcloud, meaning I use GCP, but you can use your arbitrary cloud service, for example, AWS, or since now AWS or Microsoft also offers Kubernetes service, right? So anyways, there is some initial setup. This is really tiresome. And after that, you can do this part. And important part is you use the kubectl command. And any instruction or any operation about Kubernetes is done by this kubectl command. You will only use this command basically. And through this command line, kubectl run some name and with what image, something. Then Kubernetes will start to run. And after that, kubectl expose, meaning this is the binding of the network with between internal network and external network, so that by this expose, I can access from the internet space to the Kubernetes cluster. Then after that, CRI. So that's done. And what is good point about this is there's many pros, and of course there's cons as well. But about pros, maybe I can say, and my favorite one is Kubernetes will let you deploy your arbitrary container image on any cloud service without vendor lock-in. That is really important part for me. Personally, I prefer vendor lock-in. So if you create your own service on container and write once, run anywhere is what Kubernetes will offer for you. And that is my most favorite part. So that's why I'm going to explain on this. And this is how Kubernetes and actually kubectl command will work internally. But if you have time, then maybe you can look this thoroughly later. So anyways, until this point, now you understand a very, very short version of Kubernetes, right? Okay. So Kubernetes is using gRPC through kubectl command. So that's the very quick introduction. So given this understanding, now today's objective turns out. So what is it like to create our own gRPC server, works as a CRI simulator with Ruby? That is my experiment for today's talk. Some might think this is foolish. And I understand that feeling, since the Kubernetes world is totally written and coded in Golang, I think. And Ruby is right now not used so much. And that is okay. And Golang is, of course, good language, right? But sometimes I feel that for some tasks I feel like for some tasks I would prefer to use Ruby for some tasks. And so my main motivation for this talk is there anything I want to explore or I want to see the opportunities where Ruby can do much better than the other environment. So is there any such opportunity or not is my main point. So, and this is a taken from the official trailer of Kung Fu Panda 3. If you've seen the Kung Fu Panda 3, if you haven't seen the Kung Fu Panda 3, then you must look at that really, really good movie, actually, the Kung Fu Panda 3 series. I love that. And Shifu Roshi says, if you only do what you can do, then you will never be more than you are now. So this is the phrase that I love, and this is why I decided to do this, and also I submit the CFP to the RubyConf India. Anyways, so today's scenario is something like this. So now is the time to get our hands dirty. So today we experimentally build our own container image first. So maybe we will create our own container image first. And after that, we will create our own container runtime next. And after that, we prototype the container runtime interface. So very big scenario, but I only have remaining 36 minutes something. So I will do this very quickly. Okay, let's start. So first is build our own container image. So how to do that? So do you know how to create the container image? Actually, the container image is just towable. So with very basic Unix command line, you can create your own container image, actually. That's the interesting point, isn't it? And so for here, just to explain what the container image, the turbo file is look like. I downloaded some image, container image from Docker Hub repository by Docker pull command. So it looks like downloaded, right? Then after that, Docker save command, meaning the some export command from Docker's internal management to the outside file system. So that I named it as bgbox.tar, and I extract that file onto my file system. And finally, I get some JSON file and some tar file as well, and some JSON file, etc. But you can see that very simple folder structure. Only one folder, actually, yes, only one folder and three files, yes. So only very simple files, you can create your container image, actually. And what is it like, actually, what is the contents of those files is this is just as an example, but for example, if you open the manifest.json file, then it looks like something like this. Oh, very simple. You can actually handwrite this, right? It's really fun. And there is only 3 property: config and report tag and layers, but I only have 4 minutes, so maybe I should skip this part. Maybe you can later on see this part. Anyways, the container image is really simple, but for my talk, I just create container image for simplicity reasons, rather than creating handwriting, everything, but I just take a quicker way. So meaning that just create some directory by mkdir command, and after that dev-struct command. Maybe some of you is not familiar with the dev-bootstrap command, but dev-bootstrap command is some command you can get the entire Linux folder structure. So once you type dev-struct and execute, then you will get under this lib my root folder, you will get your Linux entire file system, something like etc folder and bar folder and opt folder and lib folder and bin folder or something like that. So you will have a complete set of the Unix file system, so that you will get already the base container image file folder structure already. And after that, just use the tar command to make them to the table. And to create manifest JSON file or something, just to simplicity reason, I use the Docker, but you can of course handwrite your own JSONs as well. But anyways, so container image is such a really simple thing, so maybe we can finish about that by this sheet. Then after that, how about container runtime? So only 3 minutes, okay. So container runtime is okay. In short, there is no OCI specification compatible container runtime written in Ruby, and everything is written in Go. Okay. And this is not OCI compatible, and this is not CRuby, but actually the MRuby. But let me introduce interesting project which is developed by some Japanese person. Is Hakoniwa is actually, and I'm introducing this because actually this is still actively development. Hakoniwa is a helper tools with DSL for your handwrite Linux containers. So it's something like the wrapper to access the Linux lower level API to manage some Linux resources like C groups or namespaces or other APIs. The example is something like this. So you can control your Linux lower level API throughout the Ruby DSL, so which is really simpler and readable code, and you can control your Linux properties. And this is fun as well. And for today's talk, I created some simple container runtime-ish, container runtime-like something. And actually, this works as some container, some kind of container, some kind of runtime, I think. but which is not OCI compatible as well, of course. But anyways, so using Hakoniwa, I created some container runtime for today's talk. By the way, I uploaded today's talk's material to GitHub as well, so that you can check how the source code looks like. Maybe you can check later on my GitHub repository as well. Anyways, so you can create some container runtime now, and this is the last part. So what about the prototyping the Kubernetes CRI? Is gRPC, of course. So how to create gRPC is just use the Ruby gem. So basically require gRPC, then you will get gRPC server functionality, basically including HTTP2 server. So yes, using gRPC with Ruby is really quick and easy. You can try from today. And this is the server implementation looks like. And as you can see, it's not so much complicated, right? So creating gRPC server with Ruby is also not, it's easy and piece of cake. So you can try really easily. But anyways, since there is no time, actually already exceeded, right? So maybe I should do some quick, I should show some quick result about that. So basically, what I did is I implemented a few APIs, actually a few mock APIs of a CRI implementation, and confirmed that have worked with these source codes. So maybe later you can check out my slides and GitHub repository, and combined with that, you can understand how gRPC works, of course, how and Ruby can do that about that. Okay, so yes, that's all the takeaways. Yes, it looks like we can create our own CRI implementation, but of course, there's still many things. Actually, I mean, still many things to do. So the repository I created is just the prototype and actually mock, so that it is not far from the production level. But it's good for the learning and learning, or just for the learning, that will be good material. And this discussion part is the most important part. So Kubernetes ecosystem is evolving rapidly, but many tooling is not matured yet, I think. So that I'm thinking there is something to do for Ruby community, actually. And good thing is there is some open specification, as we've seen in this session, such as CRI and OCI specification. Open means that there is something to do for us. And yes, so the idea is there is many points to be improved. For example, I don't want to write too many JSON file, or there is too many YAML files. But instead, I want to write more readable or easy to write something. So is there anything we can do by Ruby? Or as someone explained yesterday, but there is no serverless platform Rubyist can easily use, right? Actually, AWS Lambda is only supporting the Node.js or Python or Java, right? So Ruby is not treated as not treated good. So what about to create some fast function as a service platform specifically designed for Ruby is also interesting topic, I think. Or CRI, creating CRI server is also, of course, interesting, but creating some CRI client is also kind of interesting to think or wonder what we can do. Yeah. And that is everything from me, and let us have a nice hacking. So thank you.
Thanks, Kei.
Thanks.
Do we have any questions? Yeah.
Hi, first of all, I would like to say it was a very nice talk, a very unique one.
to have in a Ruby conference.
Thank you so much.
Yeah. So my question is that you created a doc while creating an image, a container. You created it by using Docker, right? So have you in your production or in your company, do you use CRI-O, or have you thought of using CRI-O because it gives a better support to your runtime interface? Have you heard about CRI-O?
Yes, I have used Cryo, and I'm sorry. The point of question is, what is the? Yes, I have used. I
Okay,
have
no,
used Cryo.
the question is that, so in your company or while you're working into day-to-day life with
Okay.
creating, do you use CRI-O or do you use Docker? And if you use one of them, why do you use it? Like, what's
Okay.
the benefit of
So,
that?
okay. In terms of the experience, basically in the production environment, I have only used the Docker and Kubernetes as well. But Cryo, yes. I have not used the Cryo on the production, but instead I just only use the sandbox or the local environment.
I think you should try using it because I think
Yeah.
it gives you better opportunities than
Yeah,
using
yeah,
Docker.
yeah. Definitely, yes, yes. I will. Yes, that is a one of to do I need to do. Yes, thanks.
Cool.
Yeah, thanks. Go. And you, yeah.
Hi. I had a question around
Yes.
gRPC and Ruby.
Okay.
So when you actually make calls from the gRPC server, from the Ruby client to your gRPC server, have you managed to do that to, say, SSL-enabled gRPC servers?
SSL.
Yeah.
Actually, for this experiment, I just disabled the SSL.
Okay.
So have you?
Yeah, because I've had trouble doing that. I tried.
Oh, really?
Yeah.
That's interesting.
And so just a general.
Yeah, maybe after this talk, maybe we can discuss about that. Yes, thanks. Yes, over there. Yeah.
Hi.
Hi.
Actually, really nice talk.
Thanks
I
so
have a
much.
couple of questions. First is regarding CRI-O, something like Containerd, that is getting a lot of traction these days, and I think Cloud Native Foundation recommends over that.
Yes.
So my first thing is like, if something like Containerd is available, so what are the advantages of moving something like from Docker, Rocket, or something else to Containerd? And if specifically with Kubernetes, Containerd is a preferable choice. So that is first question. And my second question is, what CRI-O offers in terms of security for user? So as of now, most of the things in Kubernetes and containerization are really exciting, but about security, we are still concerned. And for legacy applications,
you are right.
For legacy applications, we are still not sure. So what would you like to suggest?
Maybe you are the one who I have talked with about yesterday. I have talked with you, right?
Yes.
And just to explain, he is working for some company, actually Big Binary, I remember.
Yes.
And as a DevOps engineer, and he is seriously using Kubernetes, so that the question is really deep, and actually that is a good point, I think. But your two questions about the CRI-O, the pros over the other container runtime, and also the security is maybe I need to add those items as a homework to me because I don't have much information about that. So, but that's the really important next step to move on for the Kubernetes community actually, so that maybe I will do some investigation about that maybe, and after that, after this conference or this month or next month, maybe I can share with you. No but problem. I'm sorry for today, I don't have much information.
No problem.
Yes, thank you for your questions. Okay. Yeah, that's the really important point.
Okay, thanks. What about security?
Yes, about security as well, yes. Yes, but yes, I need to investigate about that as well for today.
Okay, thanks.
Yeah, sorry. Thanks.
All right, thanks, Kei, for the awesome talk.